Okay, we are live.
Okay, so hi everybody, good morning, good afternoon, and good evening, depending on the time zone. This is Daniel, and this is the Zero Knowledge Learning Group uh, from Linux Foundation Decentralized Trust. It is basically a learning group for learning zero knowledge and related technologies, basically. So basically, this session is the last one this year. So what we're gonna do, we're just gonna do like a little bit wrap up, and we're just gonna take a look on one more application, which is like zero knowledge logins. And well, I would say that's all for this year, but so there's gonna be some good news as well. We probably continue this zero knowledge learning group next year as well. It's still a little bit questionable what's going to be the format, but it might happen then. It's going to be exactly the same than this year, and we're just going to have some additional content and topics on zero knowledge proofs. I mean, actually, this is like zero knowledge proof and the related technology. So that's the agenda for today. We just start with a little bit like wrap up. It's again like season one, so season 2025. We'll have one slide as usual on zero knowledge proof as a summary slide. What's this whole thing about? Then we're gonna cover something which is like zero knowledge login, which is like an innovative application, mostly used by SUI protocol. So we start with like the problem of Web3 user experience with some OAuth and OpenID basics, this federated identity with some basics, how OAuth can access blockchain, then with some specific ZK logic flow, how like an OAuth authentication can work uh, instead of keys, then the ZK part of this whole application. I'm gonna have like one demonstration and as usual, some links and resources. And at the end, again, this is gonna be the announcement for next year. We're just gonna continue the zero knowledge learning group next year, next season as well. So let me have just this wrap up slide, basically. It looks that way. So again, this is like a learning group. So I wouldn't say that I'm a professional in the knowledge proofs and applications. I would say if I do it one more year, then probably I will be an expert on this topic. But I did not start this learning group to be an expert. Basically, I'm more like an application developer, programmer, and engineer. So I'm not a mathematician. So basically, we focus on different topics throughout this year on zero knowledge group or zero knowledge proofs. Anyway, I just forgot basically the structure of this meetup looks that way, that basically it's more or less like a presentation from my side, and we can have like a small questions and answers Q&A at the end. Otherwise, the rest is just basically online on a Discord channel. But anyway, so let me just continue with the wrap up. So basically, we started somewhere in February with like general theory and definitions. Then we covered some theoretical basis in match. That was like polynomial commitment, which was like a building block for building up zero knowledge proof or a possible building block. Then interactive oracle proof, it's like a second building block for building up SNARKs. Then we continued with zero knowledge programming languages, and I would say languages and platforms as well. One example was Circum. We just covered Circum basics and the Circum a little bit more advanced. And we just covered another programming platform or language for zero knowledge proofs. That was like Noir. We covered the basics, and then I mean, we did not really cover the advanced part of Noir, but I would say a little bit like more advanced. And then from September, we focused on different zero knowledge applications. So like in September, like proof of reserve and proof of solvency algorithms for different exchanges. Then in October, that was zero knowledge machine learning. In November, we focused on rollups, and then basically this is like a wrap up. We just cover one application, which is zero knowledge login. And then again, so the structure looks that way. This is like 1 hour because I cannot do more than 1 hour basically in this highly complex topic. It's usually one presentation from my side, and then we have like a small Q&A at the end. But basically, we would encourage everybody just to take a look on the online material, and it looks that way. That basically there's a Discord channel at the Linux Foundation Decentralized Trust Discord channels. So if you just open Linux Foundation Decentralized Trust, basically, if you don't have like access for that, just Google it, Linux Foundation Decentralized Trust Discord channel, and you're gonna get an invitation. And as soon you have like access, then basically under community, you will find Zero Knowledge Learning Group. And I'm gonna post here everything. Depending on the questions, I will try to answer basically everything that I manage. It's again, sometimes it's a little bit tricky because I'm not a mathematician. So if you just, I mean, ask for very deep mathematical objects, I might not have at the moment the competence to answer, but otherwise I will try to post and answer any questions that you have on zero knowledge proofs and different similar topics or applications. Usually we are on meetups, so basically I will have this, or I had this 1 hour session each month throughout this year, and it's something we continue next year as well. So if you're interested next year, you will find the next sessions on Zero Knowledge Learning Group on Meetup as well. And basically, we have one repository. This is the repository that's like under Linux Foundation Decentralized Trust Labs. So it's basically a lab, and basically in this repo, we got here everything. This is like the whole year. So basically, starting from February, March, April, May, June, July, August, September, October, November, and I mean, part of December is still missing because I mean, that's what we are having here. But generally, you find the slideshow, the recording, even link to the meetups. Usually we have some example codes as well, or homework code, and then some links and literatures as well. So basically you will find here everything, and in the repo you will find like example codes as well that we covered during this session. So that was basically the logistic of this year, and that's gonna be the logistics next year. So we're not gonna innovate much. So that was practically the wrap up for season 1, for season 2020. And let me just take a look, or let's just continue with zero knowledge proofs. So this is like my one slide summary of zero knowledge proofs. It's usually, yeah, it's a little bit holistic, but on the other hand, it contains some mathematical concepts as well. So basically, in a zero knowledge proof or in a SNARK, usually we focus this year on SNARKs. We have two roles. We have a prover and we have a verifier. As usually in cryptography, one person is usually Alice. The second one is like Bob, and we might as well have like Mallory and some other people as well. But supposing we have just two roles, we get just the Alice and Bob. Alice is the prover and Bob is the verifier. And the prover, Alice, wants to prove something that she knows a fact practically in a way that Bob gonna really trust that Alice really knows this fact, but basically without revealing this fact. So basically, this fact will not be known to Bob. One example, for instance, is that let me just imagine a hash function. So Alice might claim that she knows like a pre-image of a hash function, and she can prove in a kind of mathematical way that she really knows this pre-image, and Bob gonna really trust Alice in a mathematical sense that she really knows this fact. But again, the point is that this pre-image will not be revealed to Bob practically. So that's the idea of zero-knowledge proofs. And there might be different proofs as well. So we might as well have like many interactions here, which of course we don't like in blockchain applications. So we like if things are non-interactive, there might be like probabilistic proofs, and there might be like kind of a final proofs as well. Okay, so that's like the idea for zero-knowledge proofs. And then just going a little bit more in depth, usually, so we can generally express many things with zero-knowledge proofs. And then this many things is like something which is a domain problem. Again, in the example, our domain problem was like the pre-image of a hash function, but it can be something totally different as well. So basically, we express our domain problem with a kind of a computation. It's like a computation model. We get like a C computation, which is some public input, some private input or witnesses, and it evaluates to a number, or it can be evaluated as a predicate as well to evaluate to 0 and 1. And the point is that basically, so this computation, I mean, it could be like theoretically like any kind of language like Java or C Sharp. But if we speak of like zero-knowledge proofs, it's more complicated because we need like a lot of mathematical structures. So this computation is generally an arithmetic circuit, which is like a kind of intermediate representation for mathematical polynomials. So generally, we program somehow with the help of arithmetic circuits if we want to define domain problems in zero-knowledge proofs. But of course, it's not very common that people know like, or people are good at programming in arithmetic circuits. So generally, what we have, usually we have like a higher level representation, computation, then we compile to arithmetic circuits, and from arithmetic circuits, we compile to polynomials. And then based on polynomials, we have like many deep level polynomial problems, like the previously mentioned, the interactive or equal proofs or polynomial commitments. And based on these polynomial properties, we're gonna get the zero-knowledge properties practically. Defining things a little bit more specifically or precisely, we get like the two roles, that's Alice and Bob. Prover is usually an algorithm. I mean, both are algorithms. We get a prover algorithm, that's P prover algorithm, that takes practically the public input, which is X, and it takes the private input, which is the witness, and it creates a proof as well. And the verifier is pretty similar. So practically, that's an algorithm as well that takes like X, which is just the public input. It takes the proof, and it either accepts or rejects that proof. So if it is accepted, then Bob is convinced that Alice really knows a fact, practically like the pre-image of a hash function. There's like one additional property here, but it's just kind of a pre-processing argument, so it might not so exciting basically. And what's important to recognize that basically in the verification or in the verifier algorithm, we don't have the private input, of course. So Bob will not see basically the private input. Bob will not know basically the pre-image of the hash function. And supposing we speak of like one special zero-knowledge kind of a family of algorithms that's like SNARK, which is like succinct non-interactive argument of knowledge. And so basically the properties that we want to see here, that our proof is small, that's like succinct. It's non-interactive, so we don't want to have like many interactions here, just creating one proof and accepting it. And the argument of knowledge is something that Alice really knows, like this fact. And it's some properties like succinct means that that's a small proof and that's easy to verify or fast to verify, which is again a property if you want to verify zero-knowledge proofs on the blockchain, on chain. And it's some other properties as well, like complete. If Alice really knows a fact, then she can practically create such a proof that Bob gonna convince that Alice really knows the fact. And then knowledge sound is like the reverse direction. So if Bob is convinced on a proof, then Alice really knows the fact, basically. And then zero knowledge means practically that on these private inputs, no information is revealed to Bob, basically. So that's like the one slide summary of zero knowledge proofs. Again, we just went in depth in several of these properties throughout this year. And let me just continue with like ZK login. So to start with zero knowledge login, we have this one general problem in blockchains. It's not a zero knowledge problem. It's just a Web3 user experience problem. And I would say the problem is in most of the blockchain and crypto application, these are the keys. So basically, anybody uses like a crypto application has like two options. One option is like using non-custodial wallets. Non-custodial wallets means that that people are responsible for storing the keys and for securely storing the keys and to some protocol risk as well. So that's the non-custodial wallets. And well, people, of course, don't like non-custodial wallets because they are risky and that's a lot of responsibility, and practically there's nobody to call if anything goes wrong, basically. And then it's just a lot of responsibility storing keys like with a backup and then in a secure way that it's just not stored. It's just not stolen. So that's like non-custodial wallets. So instead, people sometimes use like custodial wallets. So like use a provider and the provider stores the keys for the people. But of course, it has like a lot of risk as well. It's kind of a classical counterparty risk. It's kind of a classical centralization risk, and it might have some legal and compliance risk as well. So again, usually users don't evaluate these risks good enough, and then if anything goes wrong and for some reason the provider shuts down the crypto accounts, then of course it's usually like a pretty bad surprise, of course. So that's like the general Web3 user experience problem. And then basically the idea is that let me just start somehow to innovate on these things, and let me just start somehow to brainstorm and try to figure out something which helps with this problem. And the idea is somewhere in the classical Web3 world. So what we're gonna try to do in ZK login, we just try to use somehow the federated identity or federated authorization with OAuth and OpenID. If you're not familiar with the fact, practically it looks that way, that for instance, you have like a Google account or you have like a Facebook account. And then in a lot of applications, you have one option to, so like you just pick kind of, I don't know, like an online merchant application. And one option is that you just create a new account with like typing in basically like a username or giving a new email username and password. But another option is to use like your Google identity practically, or you can use like your Facebook identity. So if you just create a new account at like a new, like, I don't know, online merchant, web store or something, one option for creating your account and authenticating and authorization your account is to use the Google, your Google account, for instance, or your Facebook account. And this process, again, it has at the moment nothing to do with like blockchain or crypto. This is like a very classical Web2 user experience. But basically, this is realized by OAuth and the OpenID protocol. Okay. And basically, the idea for ZK login that somehow we try to use this mechanism for transacting on the blockchain. And it's like a little bit like counterintuitive how we can use like a very massive like Web2 user experience for a Web3 one, but there are some clever ideas how it can be realized. So first, let me just take a look how this OAuth and OpenID or federated identity authorization, or we can call it as delegated authorization and access, might work. So the basic idea is that the authorization is realized by a token. So somehow it looks that way, that we get some resource owners and we get some client applications as well. And basically we got like some resource server and we get like a different authorization server. And basically, if like somebody wants to reach certain resources on a resource server, then basically this client application should be authorized by the authorization server with the help of an authorization token. And supposing that the client application gets this authorization token, which is of course signed by the authorization server, then this client application can access certain resources on the resource server. So basically the idea is we get like a client, we can have some resource owners as well. We can have like a different entity, which is like the server for resources, and we can have some authorization server, and basically the whole authorization is realized with the help of like a token. I mean, not always, but in the most advanced cases in OpenID, there's like one token which has like different claims, and based on these different claims, the resource server can verify if the client should really have like access for certain content or not. Okay, so that's like the general idea. But basically, I mean, without just going very much into the details, what's perhaps more important, or the most important part, is that we get like one authorization token, which is issued by the authorization server, and with the help of this authorization token, we can manage to get access for something other, like another application, for instance, or certain content of another application. So there are many use cases of this. It's like the third-party login. Mostly it's like authorization. It is used like in microservice communication as well, or even like as far as I know, like mobile and desktop apps use like similar ideas as well. But again, just on a very high level, on an intuitive basis. So basically, if you have like a web shop and you just create your account, on the web shop. I'm just closing here everything because I guess it's sorry. So just imagine you get a web shop and basically you just want to authenticate on your web shop with the help of your Google account. Then practically Google gonna create you such an authentication token, which is just passed to your to the like the web shop, and then the web shop will authenticate you practically and create or gets or provides access for certain contents. So that's the general idea. So basically, the main idea is that for this authentication and authorization scenarios, we have a token, which is like practically a JSON, or it can be different, but practically in our use cases, it's like a JSON file. So this is like an example for a JSON file. It has like three other properties. It has like a meta, like a header, which is like meta info, having like the different cryptographic protocols and so on and so forth. And this is like the payload, which is like the content, which is the JSON file that provides like a few claims, like names, like scope, and like the provider, and like claims for what should these people or this token holder, which content should this token holder access practically. That's like the payload. And of course it is signed by the issuer. So if you just go back, then basically we got like an authorization server, or if we just take the example of Google, then basically Google gonna slide this token. And the idea is that basically we use this token for accessing our account in the blockchain. So basically that would be the idea, somehow combining OAuth and this token for authenticating with DApps, with decentralized applications, and initiating blockchain transactions. So the idea is somehow to integrate Web2 authentication with Web3 authentication, and practically it would be lucky if it is like in a non-custodial way. And basically the idea is that like individual addresses should be accessed by OAuth tokens and not directly by private keys. So that's the major idea. From a business perspective, basically the idea is that if you just go back like to the Web3 user experience problem, there are some, there's some discussion. Basically, a lot of people say that these access keys, especially the private keys, and having this non-custodial and custodial user experience is basically the biggest block for user adaptation in crypto and in blockchain. So if we just can somehow overcome this structure, this user experience, then that would be a huge improvement. And if you just consider basically that, let's just imagine the idea that we use like such tokens, such OAuth or OpenID protocol for authenticating with our blockchain address. That practically means that, for instance, if we have like a Google or Facebook account, our account is associated directly to a blockchain address. And if we just say, hey, yes, we authenticate, basically in this in our Google or Facebook account, then with this authentication we can transact on the blockchain as well. So that's somehow the idea, that's somehow the vision. And ZK login is one example how we can try to manage something similar. I would not say it's perfect, but it works somehow already. So let me just have like let me just draw like one picture. So basically what we want to do is that we will have like Google for the first one. That's like Google, or it can be Facebook as well. And basically with like an OAuth protocol, Google gonna issue for us one token which has like different claims. So this can be like a user ID, but this can be like provider information, provider info, but it can be like an application info as well, application info, and so on and so forth. That can be like an expiration date as well, of course, it's like expiry. And of course, this is signed by Google. So basically, what we want to do for reaching like an OAuth blockchain integration, we just want to use this token. Again, it's like a JSON file, this token, to access our blockchain address. So the way we can do it, there might be two options. So we can imagine that here's the blockchain. And then one possibility is that we just use somehow a smart contract. So there's like a smart contract on top, and basically smart contract looks that way. That's like a smart contract. If we just call somehow a smart contract, and if we just put this token on the blockchain, then basically there is something happening with a certain account. So you can imagine basically there's no private key here. So basically we don't access our account with a private key. But what we try to do, we just try to access our account with the help of this token, which is not signed by us, but basically signed by Google. And we can imagine basically that based on the token, we can somehow calculate like an address as well. So we can say like, for instance, we just get like an hash function, and based on the hash function, for instance, it's like the provider ID, and we have like the user ID. And then we can imagine that basically supposing we have like one such a token, it and if we just put it into a smart contract, then there's like an address which is generated. It's like the hash function of the provider ID and the user ID. And basically, for this address, we get authorization. So practically, it means authorization. Okay. So basically, it would mean something that if we have such a token, then based on the token, we get like an address. And then basically, so that's like the address. And if we have our address and our token, then basically we can do anything with our address. So like, for instance, we can transfer tokens from this address, supposing we have like a valid token. Okay. Certainly it's a question if that's so secure as using a private key or not so secure. Well, actually, I would say it's not. And of course, the second question is if it's so private, then using a private key. But anyway, before going into the details, so one option is like using like a smart contract, or we can say we can use like kind of an oracle as well, putting this token to the blockchain, and we can evaluate in a decentralized way with the help of a smart contract. That's one way of doing, and while actually most of the blockchains are capable of running like smart contracts, so theoretically it is possible to implement something similar. The other way is that you can implement everything in layer one. So if you implement like a brand new blockchain, then basically you can put this functionality into layer one, which is another blockchain. Sorry, that's another option. So, of course, most of the blockchains are not capable of doing it, but basically, if you do something which is like a totally new blockchain, then there's an option of doing it. Okay, so that's like the general idea. And then, well, there are some problems with this idea. So first, basically, you have here something which is like user ID. You might as well have something here which is like email. And then basically, you don't want to put this information on chain. That's for sure. Otherwise, because you don't want to put like personal information on chain. But otherwise, if you put even like the user ID, which might not be like personal information, I mean, your whole transaction history gonna be tracked. So basically, we just have the same idea, but instead of like calculating address just by these token properties, we're gonna have here like one other property, which is like a salt, which is generated by a user. That's like one innovation. And of course, instead of putting our whole token to the blockchain or layer one, we're not gonna put the whole token on chain. But what we do practically, we just gonna create a zero knowledge proof, that we hold a token which is formatted in a way with which we can generate practically an address, and we can even prove in a zero knowledge proof that practically this token was signed, for instance, by Google. Okay, that's like one thing. And then basically another thing, we just introduce one additional signing option here. So basically there's a user here, and then the user creates like a pair of keys, and that creating like such a token, the user just gonna put like the public key here and basically signs the transaction with a secondary key. Okay, so basically, the idea is that we want to use tokens for accessing our addresses. Accesses our address practically means that we can, for instance, transfer from this address, supposing we have like cryptocurrency on that, but we just don't do it in a very naive way, like putting this token on chain onto a smart contract, or like extending stuffs on a layer one blockchain. But basically, we have some additional mechanism here. So basically, this address generation is like extended with like a special salt. There's another public and private key by the user, and basically instead of putting this token on chain, what we're gonna have, we just create a zero knowledge proof that we have this token, and the token holds certain parameters. So that's the idea. And then, so basically, taking a look more on details, basically it looks that way. So this is from SUI because SUI implemented actually this whole ZK login in a very intuitive and professional way. So basically that's from SUI, but the general idea might be used somewhere else as well. So it looks for the first run, we got like a user. Now to just take a look if I can. And then basically the user wants to basically access a blockchain address. Accessing a blockchain address means like that you can like initiate transactions from that address. And for the first round, the user gonna create like a temporal public and private key. This is just a temporal private and public key, so it's not need to be like stored as much or as secure as like classical signing keys. And then basically what the user gonna do, just practically gonna log in into like Google or Facebook, and we'll create like an access token with the help of the OAuth provider. And for the access token, there will be the public key which is written into this token, and there will be one special salt which is like inserted into this token by the user. There's like an additional box here, which is a salt provider, but it's not necessarily needed. And then basically, supposing that we have this token, we're just gonna create a zero knowledge proof on that token, that we have a well-formed token. We have our public key written into the token. This token is created by a well-known provider, which is like Google or Facebook. And basically, that's all. And there's some address calculation I'm gonna show in a second. And we just put this ZK proof like in our example in the SUI network. And in SUI network, there's like a layer one validation for this token. So practically, if everything is good, everything is cool, then we're gonna have like access for our blockchain address. So that's like the whole ZK flow. So we're gonna generate like temporal keys. We generate a JSON web token. That's like the OAuth token. We put the public key into the nonce, and there are some other claims as well, which we will use for address generation. Then there's a unique sort from the client. It requires for the unique address generation and a little bit like for hiding address. We just generate a ZK proof on correctness of the token and then the signatures and so on and so forth. We identify the user address and create a transaction. So practically the address is based on like the user salt and some key claims, and then we just verify the signatures and ZK proofs. And after that, we just put everything to the blockchain. So basically the blockchain gonna send just a ZK proof and some addresses and one signature. And basically, if everything cool, then we're gonna get like access for our blockchain address. So just having the ZK part of that, basically, so just two comments. Again, the address is based on the hash value of different persistent values in the token and the salt. And salt is kind of a secret information for deriving our Web3 address. And we validate, we generate a ZK proof to prove that there's a nonce, and we just put our public key into the nonce. We just have the claims, that's like the key claims, which is the key information. And then we just check if that's consistent with the address and if that's the whole token is consistent. And then, sorry, that was two different steps. And then we just check if the address is consistent with the key claims and user sort, and we just check if the signatures are correct. Like we get like two signatures, one for the token, it's from the OAuth provider, and we have this temporal key as well. Again, we can check this one as well. So that's somehow the idea. We got like one demonstration. If I just manage it, basically it's like the whole flow is a little bit like more complex, but basically there's like an app from SUI. So you can just manage basically to follow the whole process. It looks that way. So first we generate a key pair, that's like a private key and public key. Again, it might be funny that even if we want to like authenticate with like a Google provider, we have like still like a public key and private key. But the role of this private key and public key are not exactly the same as with like a classical signature key. So these keys are temporary. So if you lose them, it's not such a big deal. Basically, they can be like newly generated. So that's like the first step. The next step is that there are some extra things here, like getting the epoch from SUI, generating some randomness, and basically we just generate a nonce. Again, nonce is like a hidden value, basically for us to generate the address that we want to reach. It's like kind of an extra secret information. And if you have this one, then we can sign it with Google. So practically, I'm using an account. I hope it still works. So I just signed it with Google, and basically what I'm having here, I get an authentication token from Google, and this is like the base 64 encoding of my authentication token. But if I just decode it, basically I get like many parameters. So basically I get here the provider name. That's like, I guess, the application. I got like the nonce. I'm not quite sure why I have the nonce. Yeah, that's the nonce for some reason. But anyway, that should be my public key. I'm not quite sure if that was the public key in the first step, but anyway, then we can have some other properties as well. So for instance, somewhere we have something which is like a user ID. I'm not quite sure which is my user ID here. Perhaps that's like a client authentication. Probably this is my user ID, I would say. So this is like an authentication token. Again, but this authentication token has been extended with like a public key that I just generated in the first step. And supposing I got this one, we can generate a salt. Basically, this is my salt. This is my extra salt. Again, it's theoretically a random number. And then basically after this one, based on many different properties, and these are the properties that are used for address generation. Practically, I have like I'm not quite sure which one is which, but one is like if you just go back, we can take a look. I think out was the Google, that was the provider name. Perhaps ISS was the like the client ID, and sub was my user ID, if I'm not mistaken. And in order that this user address is not visible to the whole world, or not so easy to be figured out, we get this user salt as well. So practically we use like the hash of these three values, and we get the blockchain address based on that. So we can just generate based on this information the address, and this is like a blockchain address basically. And based on our blockchain address, we might as well request like test SUI tokens as well. So in the next, what we're gonna do, we have like all the information. So basically, we can say, I'm not quite sure which one is this, generate temporary public key, but basically at the end, what we can do, we can just generate a ZK proof, and that's our zero knowledge proof. Again, as usual, it's just I mean, you can't say much on based on such a cryptic zero knowledge proof, but that's actually the whole thing. So with this zero knowledge proof, basically we just proved that we have like a token which was signed by Google. It contains like one special public key from us. And then we can even prove that this token is well formed, and we can prove as well that our address was generated based on our properties that we covered last time. And basically, if you send this proof to the blockchain, again, if you don't use SUI, then you could theoretically implement something similar in a smart contract as well. But basically in SUI you use like layer one, and then basically if that's authenticated, then you can get access to your account. So I'm just having next, and basically if I have everything, probably I don't have like access, I don't have balance basically, but theoretically, supposing I have everything, I can execute the transaction, for instance, on the SUI network. It says I don't have coins, so basically I should have like initiated some or get some test token for this example, but supposing I have like some test tokens on my newly generated account, then basically based on this information, I can initiate the transaction on the blockchain. So that's like the idea. And well, of course, so generally the question, how good is it? So what about like security and privacy? And that's like a more complex question, because yeah, I mean the things is pretty complex. So it has like, centralized parties like the Google authentication or Facebook authentication, and it has like more decentralized parts like the blockchain and some user initiated elements as well, like the salt or the temporary public and private key. So like investigating security and privacy, or generally assessing advantages and disadvantages of such a system, is kind of complex for the first round. So I just have some hints. Basically, uh, it looks similarly as a two-factor authentication model, because basically on the one hand we use like the OAuth authentication like from Google or Facebook, and there's like a private salt as well. So supposing this private salt is not known by the authenticators, or by the OAuth provider, then basically the OAuth provider cannot create like transaction on behalf of us. So it's like a two-factor authentication model. Of course, I mean, so it has like the same problems as private keys generally in blockchain, because they should be kept private unless we don't have problems with that. Then we have like a temporary private key. It's not exactly the same as like assigning private key on a classical blockchain address, because it's not such a huge problem. If it is lost, it is just temporary. It has some expiry date as well. Then we get like some privacy. So privacy is good, as or basically until the salt is kept private, then basically we get good privacy. But if it is for some reason revealed, then we're gonna have like a problem. And then of course we might as well have some counterparty risk. So we can imagine what should happen if like the OAuth provider just shuts down, or our account in the OAuth provider gonna be blocked for some reason, like Google inaccessibility, or like deletion of our account from Google or Facebook, that might cause problem. So generally, I would say that's a very, very good and innovative initiative. It's a little bit complex for the first round, but I would say probably on a long run, such a hybrid models are gonna be improved. And even if it is like not perfect for the first round, again, this is like a very, very interesting direction of combining like classical OAuth-based tokens or OpenID-based tokens with blockchain access. And of course, the key block for this is like zero knowledge proof, because I mean, that's the tool with that you can just create practically the necessary cryptographic primitives. So I got one challenge for the end. Practically, it's not a developer challenge. It's just like, if you feel like experimenting with, just test the ZK login with an own authentication provided on a test network. You can use like, or you can take a look actually like this demo application as well, but there are like some other demo applications as well. And I've got some links and literatures at the end, so you can take a look practically on ZK logins. And I would say that was practically on ZK logins. So I have one more slide. Basically, that's like announcing the Zero-Knowledge Learning Group for next season. And then basically the idea is that I generally continue this ZK Learning Group. I hope there's gonna be interest. Uh, I'm not quite sure if I manage it every month, but at least in every 2 months there would be a session. Probably sometimes I manage even every month, every month as well. The structure is pretty similar, so it's gonna be like one lecture from my side, or I try to invite guest lectures as well. So it's like a public announcement. So if you feel like you have some, good topics in zero-knowledge proofs, and you feel like making presentation or making like a session on this in this learning group, that you are more than welcome. There are some zero-knowledge initiatives like labs at Linux Foundation Decentralized Trust as well. So I try to invite practically these groups as well to have like one guest lecture throughout next year. So that's the idea. I'm still not so sure about the logistics, so it might not be like the. I mean, this year it was almost like the third Thursday of the month, but perhaps it's just gonna be like the last, or especially with guest lectures, it might happen that it's gonna be like even more chaotic, because so the schedule might not be so fixed. And then the other idea is that I try to continue what basically I just planned this year. So we're gonna have like 3 building blocks. First, in like January, February, March, I will try to continue with some theory, and I will cover, or I'm gonna cover like topics a little bit more like on a theoretical level, which we did not cover this year. It's gonna be like, for instance, lookup tables. There's gonna be like zero-knowledge variations like STARKs. It's pretty popular, or even SNARKs. I'm not quite sure if I manage it. And then if I manage, there might be like even something with recursive SNARKs as well. So again, this is like a theoretical part. We're gonna have like a middle 4 sessions on programmings and platforms. I'm surely plan to have or introduce like Zincs and ZK Sync. Zinc is the language, and ZK Sync is practically the platform. So that's surely interesting. The second one I picked is like Leo. But I mean, if you have like any other or any better ideas, or more interesting platforms, or ZK programming platform, just let me know. And then on applications, I have some other ideas as well, which we did not cover this year. One is like private transactions. Well, we covered partly a little bit like with rollups, but rollup is not necessarily focused on privacy, so it might make sense just to have like a separate session on private transactions, like with Zcash and stuff like that. Then one session on zero-knowledge virtual machines, which is a very interesting topic. Then perhaps one more session on zero-knowledge identity, or like if you think of like verifiable credentials, there's like the presentation part of verifiable credentials, which is done by zero-knowledge proofs, and perhaps at the end something which is related to voting, which might not necessarily be directly a blockchain application, but it can be perhaps applied with like blockchains as well. And then voting is certainly like, generally an interesting zero-knowledge application. And logistics gonna be the same. So basically, we're gonna use the same Discord channel. Each like session gonna be announced in Meetup, and then basically I will just continue to manage the repo on Linux Foundation Decentralized Trust Labs with all the material that we have. So that was all for today. So I would say we got like 3 more minutes. So if you have like, I mean, like small questions, I can try to answer. If you have like, more in-depth questions, then probably I would encourage just to use. I'm not quite sure. Okay. I'm just reading the chat as well. So if you have questions, you can unmute yourself and ask, or you can just put it into the chat as well. So it's up to you. So I can share the Discord. I'm just sharing the Discord. Looks like the Discord link. I'm just sharing it. The GitHub link as well. So that's like the GitHub link. And anyway, it is streamed. It will be available on YouTube. So if you just go to YouTube under Linux Foundation Decentralized Trust, basically you will find this session as well. So basically, I share yeah, I would not go to the YouTube at the yeah, okay, we find YouTube. So I'm gonna send, so the presentation itself will be found here on GitHub, but basically I will just put the presentation on Discord as well. So I will put the link of the presentation on Discord as well. But basically, if you take a look on the repository, there you will find the presentation as well. I think it is already linked. So basically, that's the slideshow. So if you just go to like the repository, you will find the 15 December, and you will find here the slideshow basically. Yeah, so I would say we would have like one very fast time for one very fast question, because yeah, due to our time limit.
Okay, I'll ask. So, I guess my understanding of ZK in this context, the idea is to make the user experience easier, so the user doesn't have to manage public and private keys. But it seems like with this, they still have to manage a private salt, and if they lose the salt, then they're in trouble. Am I missing something? I'm not sure that there's a benefit to the user here.
Yeah, that's correct. That's correct at the moment. Yeah. So there are options. For instance, so for instance, in SUI, as far as I know, they give you like a salt service, storing your salt, but then it's not so private. And yeah, so it's still not perfect in a sense that basically, if you want to have like full privacy and then basically unhackable, then you still need to store like a salt. And yeah, yeah. So in a sense, it's still not perfect, I would say. So it still not give like the experience that, just use out, and that's all. Generally, I would brainstorm a little bit on the applications as well. So this might be not like an application for like storing a lot of cryptocurrency. I mean, just imagine the fact, if you want to like store, I don't know, more than $1,000, probably I would say don't use this structure. But if you use like kind of an online gaming application, and you need like pretty fast access for your accounts, then it might be like a good combination. Yeah. Okay, so if we don't have more questions, I mean, again, if you have like questions in the future, just feel free to drop the question and in the Discord channel under Linux Foundation Decentralized Trust, and yeah, I will try to answer as I
Do
can.
we need do we need an invite to the Discord channel? I've clicked the link, but it's saying maybe I don't have access to the server.
So I would say probably you need like Linux Foundation Decentralized Trust Discord, and probably you got the Discord here. So I'm just not quite sure if I just copy the link. Copy link. Probably you can just try this one. I guess that's the Discord. Yeah, again, so I'm not quite sure if you can just access this
Oh, yep, that
this link without invitation, but again, if you just Google it, you will find, and then if that link doesn't work, basically you just find under community, and then in communities, just at the end, we get something which is like a zero knowledge learning loop. Okay, and that's it practically. Okay, so I would say thank you very much for today, and thanks for your attention. And then we're just gonna continue next year, and then well, happy holidays for everyone.
thanks a ton.